Materials characterization. Materials characterization is a crucial aspect of materials science and engineering that involves the analysis and understanding of the structure, properties, and performance of materials at various length scales. By characterizing materials, scientists and engineers can gain insights into their composition, microstructure, mechanical behavior, electrical properties, thermal properties. Here's an overview of materials characterization techniques and their importance. 1. Microscopy. Optical microscopy uses visible light to observe the surface morphology and microstructure of materials. It provides information about grain size, surface features, and defects. Scanning electron microscopy provides high-resolution images of material surfaces using a focused beam of electrons. SIM can reveal details at the nanoscale and is useful for studying morphology, composition, and microstructural features. Transmission electron microscopy (TEAM) allows for the visualization of internal structures and features at the atomic scale by transmitting electrons through thin material samples. TEAM is essential for studying crystallography, defects, and interfaces. 2. Spectroscopy (DX) ray diffraction. XRD determines the crystallographic structure of materials by analyzing the diffraction patterns produced when X-rays interact with a crystalline sample. XRD is used to identify phases, crystal orientation, and lattice parameters. Fourier transform infrared spectroscopy (FTR) measures the absorption and transmission of infrared light by a material, providing information about chemical bonding, functional groups, and molecular structure. Raman spectroscopy analyzes the inelastic scattering of monochromatic light by molecules, providing insights into molecular vibrations, crystallinity, and chemical composition. 3. Mechanical testing. Tensile testing measures the mechanical properties of materials under tension, including tensile strength, yield strength, elongation, and modulus of elasticity. Hardness testing determines the resistance of a material to indentation or scratching, providing information about its hardness and wear resistance. Impact testing assesses the toughness and impact resistance of materials by subjecting them to sudden loading under controlled conditions. 4. Thermal analysis. D-differential scanning calorimetry (DSC) measures the heat flow associated with phase transitions such as melting, crystallization, and glass transitions, providing information about thermal properties and stability. Thermogravimetric analysis (TGA) determines the changes in mass of a material as a function of temperature, useful for studying decomposition, oxidation, and thermal stability. 5. Electron microscopy (DE-energy) dispersive X-ray spectroscopy (EDS-EDX) provides elemental analysis of materials by detecting characteristic X-rays emitted when a sample is bombarded with electrons in SEAM or TEAM. Electron energy loss spectroscopy (EELS) measures the energy loss of electrons passing through a thin sample, providing information about elemental composition and electronic structure. 6. Surface analysis (TX) ray photoelectron spectroscopy (XPS) analyzes the chemical composition and bonding states of surface atoms by measuring the kinetic energy of photoemitted electrons. Atomic force microscopy (AFM) images the surface topography of materials at the nanoscale by scanning a sharp probe tip over the sample surface. AFM can also measure mechanical properties such as stiffness and adhesion. 7. Electrical characterization. The electrical conductivity measurement determines the electrical conductivity, resistivity, and carrier concentration of materials, providing insights into their electronic properties. Hall effect measurement measures the mobility and carrier concentration of charge carriers in semiconductors and conductive materials. Materials characterization techniques are essential for understanding the structure, property relationships of materials design and development, and optimizing material performance for various applications across industries such as aerospace, automotive, electronics, healthcare, and renewable energy.